friends. Welcome to Module 1, Lesson 13. I'm Mrs. Gradney, and today we'll be using the standard algorithm for subtraction, decomposing to smaller units once, and applying the subtraction algorithm to solve word problems using tape diagrams. Here's what you'll need for our lesson today. Let's get started. Read this problem with me. 4,259 minus 2,171. I'll draw a tape diagram to model this problem. Now, what's the whole? The whole amount is 4,259, and we can label that at the top. We make sure to draw our arms going end to end to show that the whole tape has a value of 4,259. I also need to label the part that we know, 2,171. When we think about how big to draw the parts in our tape diagrams, we can use estimation. Here, I know that 2,000 is half of 4,000. So tell me when to stop to draw my part. If you said stop somewhere around here, way to go. Now I can label the part that we know at the bottom, 2,171. And we can label the part that we don't know yet with a variable. I'll use A this time. Pause the video now and record this problem vertically, like mine is, and also draw the tape diagram. Now we're going to model this problem using place value disks on our place value chart. When we're modeling subtraction using place value disks, do we need to draw disks to represent both numbers or just one of them, and why? Pause the video to talk out your thinking. Hopefully you said that we only need to draw disks to model the whole, 4,259. The part, 2,171, is already part of the whole. It's inside the whole. Pause the video now to draw disks to model 4,259 on your place value chart. As we subtract using the standard algorithm, we're going to be asking ourselves some questions over and over. The first question is, are we ready to subtract? We'll determine if we're ready to subtract by looking across the whole from right to left to see if there are enough units to subtract. Here's the next question we'll ask ourselves. We'll look at each unit and ask ourselves if there are enough of that unit in the whole to subtract the number of that unit in the part. Let's start with the ones place. Are there enough ones in the whole to subtract the ones in the part? Yes, there are enough ones because 9 is greater than 1. That means we're ready to subtract in the ones place. Let's move to the tens column. Are there enough 10s in the whole to subtract the 10s in the part? No, there are not enough 10s because 5 is less than 7. So where can we get more 10s? We can get more 10s from the hundreds. Watch what I can do. I can decompose 100 into 10 tens. Now I have 115 tens. I can show that same thinking in the algorithm, like this. I had 200s, but I decomposed 1 to make 10 tens. So now I have 115 tens. Pause the video to show these changes in your place value chart and in the algorithm like mine. Now let's move to the hundreds and see if we're ready to subtract. Are there enough hundreds in the whole to subtract the hundreds in the part? Yes, there are enough hundreds because 1 is equal to 1. Are there enough thousands in the whole to subtract the thousands in the part? Yes, there are enough thousands because 4 is greater than 2. So are we ready to subtract? Ready, 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 ready. I always like to go back and double check each column just to make sure I didn't miss anything. So yes, we are ready to subtract. So let's subtract. 9 ones minus 1 1 is 8 ones. 15 tens minus 7 tens is 8 tens. 100 minus 100 is 0 hundreds. 4 thousands minus 2 thousands is 2 thousands. Let's say the whole number sentence. 4,259 minus 2,171 equals 2,088. So what's the value of A in our tape diagram? The value of A, our unknown part, is 2,088. So we can record that underneath our tape diagram like this. So what can be added to 2,171 to result in a sum of 4,259? Well, in our tape diagram, we can see these two parts, and we know that two parts can be added together to make a whole, or the total. So 2,088 can be added to 2,171 to equal a sum of 4,259. Let's try another one. Let's read the problem out loud together. 23,422 minus 11,510. Pause the video now and record this problem vertically like you see here, and also draw a tape diagram to represent the problem. Label the whole, the known part, and label the unknown part with variable B. Welcome back. Do you remember the question that we ask ourselves first when we want to subtract? Are we ready to subtract? So let's look across the digits from right to left. Are we ready to subtract? No, we're not ready to subtract. So let's get ready to subtract. Now we'll go to each column and we'll ask ourselves if there are enough of that unit in the whole to subtract the number of that unit in the part. Let's start with the ones place. Are there enough ones in the whole to subtract the ones in the part? Yes, there are enough ones because 2 is greater than 0. Are there enough tens in the whole to subtract the tens in the part? Yes, there are enough tens because 2 is greater than 1. Are there enough hundreds in the whole to subtract the hundreds in the part? No, there are not enough hundreds because 4 is less than 5. So where can we get more hundreds? We can get more hundreds from the thousands. We can decompose 1,000 into 10 hundreds. So then we'll have 2,000 and 14 hundreds. Now we're ready to subtract in the hundreds. Let's move to the thousands. Are there enough thousands in the whole to subtract the thousands in the part? Yes, there are enough thousands because 2 is greater than 1. And are there enough 10,000s in the whole to subtract the 10,000s in the part? Yes, again, because 2 is greater than 1. So are we ready to subtract? Ready, 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 ready. Yes, we're ready to subtract. Pause the video now and subtract each unit. As you subtract, whisper the subtraction in unit form. Did you find the difference to be 11,912? Now we know the value of B in our tape diagram is 11,912. So look at your tape diagram. What can we add to 11,510 to get a sum of 23,422? We can add 11,912 to 11,510 to get a sum of 23,422. So then how can we check our answer to a subtraction problem to make sure that we did it correctly? We can add the difference to the part we knew at first to see if the sum we get equals the whole. If it does, we know we did the subtraction correctly. If it doesn't, then we need to go back and find our mistake. Pause the video now and check our subtraction by adding 11,912 and 11,510. So what sum did you get? Hopefully you got a sum of 23,422. What does that tell us? Since it's the same as the whole in our subtraction problem, that tells us that we subtracted correctly. Let's try a word problem now. Remember, when we solve word problems, we use the RDW process to help us make sense of them. We read, we draw, and we write. So let's read the whole problem together. Ready? Read. The paper mill produced 73,658 boxes of paper. 8,052 boxes have been sold. How many boxes remain? Now, before we dive in and start drawing, let's take a moment to think about what we know and what we're looking for. Pause the video to talk out your thinking. I was thinking that we know the total amount of boxes that the paper mill produced, and we know how many boxes have been sold, and what we're looking for is how many boxes they still have. Pause the video now and draw a tape diagram to represent the problem. Represent the unknown using a variable. Welcome back. Does your tape diagram look similar to mine? What can you tell about the relationship of the numbers by looking at our tape diagram? Use the words part and whole in your explanation. Hopefully you said, we know the whole. That's the total amount of boxes of paper that they made. We also know a part of the boxes that they sold. And we're looking for the other part, the boxes that they still have. When we know the whole and a part, and we're looking for the other part, we can subtract. Pause the video to set up the subtraction. Be careful to line up the units, ones with ones, tens with tens, and so on. Are we ready to subtract? No, we're not ready to subtract. So pause the video now, get ready to subtract, and then complete the subtraction. Check your work using addition, and be sure to write an answer statement. Hopefully you found 65,606 boxes remain. Compare your work with mine and make any changes if you need to. I think we're ready for the problem set. Your must-do problems for the Lesson 13 problem set are on the screen. Set a timer or watch the clock for 10 minutes and work on these problems. If you finish the must-do problems before the 10 minutes are up, feel free to try any of the other problems on the problem set. Today, we used the standard algorithm for subtraction to solve word problems, and we checked our work using addition. Remember to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!